Okay, so we built the shapes out of Zome. Tell me some things that you notice about the shapes. Pick either one is fine.
Well, I mean, both of them, I guess, were actually pretty easy to build.
Okay.
Just one repeating pattern. Like, anytime you see, in this shape, anytime you see a dodecahedron, surround it with triangles.
What?
Anytime you see a pentagon, surrounded with triangles.
Okay. All right.
In this shape, anytime you see a square, surrounded with triangles.
What do you do when you see a cat?
Well, also, in the cube octahedron, it's surprising because you can make shapes with like squares and triangles. You can't make the cube octahedron out of blues.
Yeah, it didn't seem like we could make it out of blues, but greens came to the rescue.
You can make both squares and triangles with blues, but you can't make a cube octahedron.
Okay. So that's the cube octahedron. We're going to come back to that for the second part of our project. But what are some things about this other shape, which I think is called the Ikasi dodecahedron?
Well, it's like we thought. We had the ring of triangles around this pentagon on the bottom too, and then we had like this layer. We had two layers. One triangles 1, 2, 3, 4, 5, and there's a lower one. 1, 2, 3, 4, 5. So it had, and it also had the same number of pentagons that we anticipated. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Okay. I'm interested to see if you can tell me some things about the symmetry in these shapes.
Well, this seems to have five-fold symmetry.
Okay.
But when you make it go like this, it has threefold symmetry.
Interesting.
And here it has fourfold symmetry.
And threefold symmetry.
Okay. So do you think these shapes have the same symmetries as any other shapes that you know?
Well, I mean, they have the same, this shape has the same symmetries as a cube, or some of the same symmetries as a cube, and some of the same symmetries as an octahedron.
Okay.
And this one has the same as an icosahedron and a dodecahedron.
Yeah, it's interesting.
Also, we might be able to give it twofold symmetry along this line here.
Oh.
Also
Oh.
twofold.
And that would make this have twofold.
Fascinating. So we've got maybe some real similarities with some of the platonic solids.
Yeah.
Okay, so for the last part of this project, we're not going to do it for the Ikasi dodecahedron, but for the cube octahedron, we are going to try to find the dual of it. Do you remember what the dual is?
So it's when you connect up the center.
Yeah, it's when you connect up the centers of the faces. And it's going to be a little bit of a challenge because I don't think we can use Zome to find the center of the triangles. Actually, can you move the blue shape out of the way? I'll zoom in on this. Move the camera over. All right. I don't think we can use Zome to find the center of the triangles, but we definitely can use Zome to find the center of the squares.
Yeah.
So what we'll do is we'll find the centers of the squares, and then we'll see.
Approximate.
Well, we'll just see if the Zome balls then that are on the centers of the squares give us any hint, and we'll try to connect them up and just see if we can. Even though we can't find the centers of the triangles with the Zome directly, maybe when we find the centers of the cubes and connect them up, maybe that'll give us a hint. All right?
Yeah.
All right, so let's go ahead and do that.